Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, December 15, 2021. Time is 3:44 in morning, early morning. नमस्कार, मेरा नाम सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिसंबर 15, 2021 और दिन है बुधवार, वेंसडे। टाइम इज़ 3:44, 3:44 सुबह के। और वही टाइटल दोबारा गुणवत्ता का, क्वालिटी का, Civil Field Engineering, Life Engineers, Concrete Specifications, Quality, AnnexSL, and various contract books as usual, just references to those, and Designs and Constructions, Methods and Contracts, Disputes, Organizations, Communication, Coordination, whatever is given there. In general, this talk is as usual, means covering various issues, quality issues, and all other issues in addition to these certifications that I try to share with you for information that these can be available. It depends on engineers, it depends on what they prefer for, and this also another certification. We know well that previous was International Professional Engineer or Professional Engineer, two categories. International Professional Engineer applies to whole world, whereas Professional Engineer applies to respective countries. And this chartered engineer certificate in India, and this also, we are talking of India, and this is according to Royal Charter of Institution of Engineers, which was granted to it by King George V in 1935. And this is membership certificate, that is fellow membership. There are three membership: associate member, member and fellow, AMI, MI and FIE. This is FIE certification, which is given to those who apply for this and who are graduate engineers minimum, and they have at least 40 years age and about 15 to 20 years professional experience, or they are retired. And this is your quality file as usual. So I'll take this care of this and close this certificate of Chartered Engineer India, and I close the certificate of fellow membership, and I open another file, and that is concrete file, which is concrete from Qatar. That file is here. You can see that file. It's important file of specifications, and you know what is meaning of specification in engineering and in works. Specifications is chapter 5, or you can say section 5 of QCS 2014, and QCS stands for Qatar Civil Specifications. This is very important chapter, very important file, very important section, because concrete is very important all over the world. And this is my identification indicatively. This is name and title of first title, then second title. That is Chartered Engineer as first one, and International Professional Engineer second one, Antarashtriya Professional Abhiyanta and Chartered Abhiyanta, Bharat. Of course, my professional field is civil engineering, and my email ID is, you can say, suraj_engineer@yahoo.co.uk. You can note it down if you wish. And of course, I belong to Bharat, India, citizen of Bharat, India, and I am resident in NCR, Delhi, that is Faridabad, near Delhi. And of course, you can write to me if you wish on this email ID. If I find your question is relevant to my profession, or I am able to answer to that, to respond to that, I shall be glad to respond on that, provided question is right, question is clear. And then you can say the certification, and I go to quality, which is based on various materials, resources, human resources and equipment, of course, engineering formula, engineering methods, procedures. When I say formula, it doesn't mean design formula, it means format of procedures. Formula means how we have to do something, and every word is based on communication and coordination, which is given top priority according to my understanding. I think that communication and coordination are very important subjects. You may call it subject or you may not call it subject, but for me, it's more than a subject. I consider communication and coordination are very important subjects in life, and in profession as well. Otherwise also you can see, if you can communicate properly, rightly, in a way it is required, and also you can apply that communication material onto work of coordination, which coordination work is very significant from point of view of solving problems, particularly technical problems which cannot otherwise be solved. That coordination, it's material coordination, or it is coordination among professionals, or coordination among others. Meaning of coordination actually is very high. It's not, don't go to article meaning of this. Similarly, meaning of communication is also very high. Don't just go to article meaning of communication, because it can be expanded. Article meaning does not mean anything except to understand what does it mean. If you open dictionary and find meaning of communication or meaning of coordination, you'll find something only, but coordination and communication are very much integrated and exploratory terms. In professional experience during my career, career of more than 3 decades, I discovered, I actually felt and scientifically realized and technically realized, if I don't have capacity to communicate, which means I should have capacity to patiently understand everything, every material given to me or find through coordination, or I collect whatever information and analyze that information, whatever it is, and after analysis link those all nodes of information in a way that I can reach certain solution which should be reliable. And that procedure, that actual linked study, you can say, connected study, can be called coordination, and combination of that, or you can say result of that, you can say it can be called work of communication coordination. And in engineering world, in engineering designs, engineering construction, communication and coordination are very significant terms, because without communication one cannot draw anything, one cannot write anything, one cannot communicate anything. If I have to communicate my mind, either I have to write that point to point, then I have to explain every point, and then I have to analyze every point, and of course I have to then find certain results and summarize, or you can synthesize them, and then I have to give conclusion on that. That is what is communication. And after conducting such communication for every issue, then we have to link all those detailed descriptions or elaborations, and then reach certain answer that this can be done properly, which can result in certain application, and that application is actually engineering application, or you can say combination of all such applications called engineering business, engineering work. And that coordination is very difficult, in fact, if you do not focus on that. If you concentrate that and you run on that track from start to end, you get some response, you get some profile of that work. You can say profile is generated. Just like we create our profile, we generate our CVs, it's like profile, and we connect from beginning till end. And we can say, okay, this is my personality of profession, this is what I can do. So every work in engineering, otherwise also, depends on complete coordination, and coordination is actually very high profile topic. We can call it coordination engineering. Just like there are so many branches of engineering, there is no such branch and there cannot be such branch, but it is required, you can say it is unrecognized but important. Unrecognized in a way, people don't study in name of coordination, but whatever study they conduct, it is coordinated study. If you do not have coordinated study, you cannot understand anything. It's like formal name. We can say coordination is a formal name of some subject which is not visible. Just like we say, whatever we can say, that I have to study something, I cannot study just by title. I cannot study just without references. I cannot study without any required feedback. I have to find information, imports of information, collection of information, study of information, and analytical breakdown of information, and then finding necessary materials out of that, and then combining all those materials, and then seeing what is objective I selected. Am I going to get that? And that is called a kind of coordination. It doesn't mean I say ordinate, coordinate. Coordinate means when you are on x or y axis in mathematics, graphics, y axis is called ordinate and x axis is called abscissa. So it says ordinate. Let us take ourselves to that reference only. I am not saying that coordination starts from there, but just to comprehend what I am talking about. Values on y axis may be lower or higher if you put many values there, but when you connect those values, it constitutes a graphics, and that graphic is a result of ordinates. And you can say when this profile is formed, you can say sine curve is formed, or some other curve is formed, or some geometrical pattern is formed. That is result of coordination. So coordinate means whoever is involved there, whatever information is involved there, that information should be collectively used. And that's what we can say collective work in a proper manner, proper style can be called coordination. Though you know what is coordination, but care is required for that. And in construction world, in design world, if we do not coordinate, we cannot give a comprehensive, we cannot give a apprehensive, we cannot give a reliable form of requirement. We cannot say you have to do this. It's like a square, if you consider a square, there are four sides, and if one corner is broken, you cannot say this is a square or a figure. Same if a triangle exists, there are three corners. If one corner is broken, a triangle shape is over. That's what I say. Every corner should be understood, and corner to corner, periphery and its coverage must be clearly analyzed and understood. So I am stressing on this because we missed it, and we have missed it. We have missed documentation. Though it is done, we say we have computers, we can do it. Well, computer is something different, we can use that, but computer cannot do it. It can do only when information is fed into it in form of database. Only then computer can work. This means it is not original work. Ultimately we can use it, but it cannot use me or you. Therefore documentation is a must. Without documents, drawing is a document. For example, we say, okay, I have issued you drawings, I have issued the specifications, I have issued details, I have issued everything. So you have all documentation. Document is something, it's not only on papers, it can be in form of videos, it can be in form of messages, it can be in whatever form. Purpose is whatever information is available, that information must reach its user. If that information doesn't reach its user or its applicator, you can say rather than user, I should say applicator, because information or a combination of information are required to be applied on some activity. So you may say it is intermittent application for some final application, or you can say it's to be used permanently or temporarily on some activity. So what I say, we have to change our thinking. We are in engineering, at least we have to be a little smart. I'm saying it because current generation is having very fast approach in doing whatever work is required. Patience is not available. That patience has gone into history. I don't know where it's gone. It's like, in air it is. In profession, patience is required because patience means concentration can be worked on. You can concentrate, and for that information is necessary, And to understand information, you cannot panic, oh, I have got these 15 points and I have to understand them, I have to analyze them. I don't have that much time and I have to read very fast and to answer it today. That is not necessary. That's why I say we are going to construct something for, let us say, 50 to 100 years, and it will take at least 1 or 2 or 3 years for that construction of that structure or object. And if you don't have time to know about that, if you can't apply some hours, few hours, means you cannot answer that. Total understanding is defined in the specifications. Vinirdesh, we can say, it's like kind of, you can say, kind of technical direction. It's a kind of analytical direction. It's a kind of concrete direction that is required. And we must respect that. And if we cannot do that, this means we waste our time. We say that it is responsibility of designers, it is responsibility of design specifying engineer to include demanded technical activity. What is that? Quality, safety, health and environment, value of ergonomics, understanding of contracts and products. These items that I have put in are very prominent and preliminary. Quality is very important. It doesn't apply only on testing. It applies even in every approach. For example, I'm talking, I'm speaking. It should be quality speech. And quality means it should not be here and there unduly. It should speak to point, it should link to points, and then it should result in something that others can understand why I spoke for half an hour or 5 minutes, or why I spoke for 3 hours. Was it required? If I can explain something in 5 minutes, why should I take 1 hour? For gossipism? No. Quality means whatever you do, it should be merit. It should be on merit. Similarly, safety, health and environment are required everywhere. It's not only in human use, it should be in material use, it should be in procedure use, it should be long-term use. Whatever service is given by some objective, by some object, by some structure, that service should be safety based, and that is quality of that. That should be health based. If in some building health is ruined because of no ventilation, because of no good material, you cannot say that your building is sound one. And same way environment. If we cannot keep environment in a good condition, as we have not done it, we have absolutely ruined it. And that's why we have been suffering. We have been suffering by impact of various diseases because of we spoiled, we polluted, we putrefied environment. You call it in terms of pollution. And also ergonomics, that's very important part. If I can do something with my energy, why should I use more energy on that? Because maybe I can't understand I am using energy, but I am using energy. I use energy all the time. So what I say, these are 3 theoretical or you can say in principle requirements without which maybe we do not identify the time it happens, but we have to take into our consideration professionally when we work on activities in engineering designs or engineering construction or whatever activities in life. Because only construction is not engineering, design is not engineering, whole life is based on engineering. Contracts is another means, it's another way how to get work done. If it is mass scale work, for small activities we do ourselves, we don't give contracts because in home we stay, or small items, or you say whatever we do, we don't give contracts, we do ourselves with support of some other people. And of course products. Products means what? There are thousands of products in life. What we define, what we talk, what we describe here is only for product. If that product is based on these inputs, you can say these points. Product can be called quality product depending on what percentage of quality has been put into that. And if you don't have all these into that product, then that product in fact cannot be called quality product. and it's, you can say, rubbish, you can say it is scrap, you can say this is. Then we can say, who is responsible for that? First, I would say whole public is responsible, user is responsible, because user should first recognize what is quality, how does it work, and that's the only reason I'm trying to share this information, whatever in my mind, based on my experience of long years. I'm not saying I'm very experienced, but in relation to life, I have some information about quality. Not because I qualified some subject or qualified degree in quality. No, that's not required. Understanding is required. Quality always is there. It was always there. It shall remain always there. Only variation is that level of quality. And quality is very important as far as engineering is concerned. We say engineering means civil, electrical, mechanical, agricultural, electronics, aerospace, mining, or you can say architectural. Whatever engineering has been classified, it has been classified because of you can say expanded technologies, expanded quantum of study. We cannot say there is only one engineering. There may be time, the first time only few engineering were there. In my own life, I could only know that when I joined my university, electrical, civil, mechanical, and all that, because of status of development. Now expansion has been allowed all over the world. So we can say quality is also expanded. We can say textile engineering, you also can say aerospace engineering, or you may say further engineering subjects in that engineering, environment engineering, public health engineering, water supply engineering, sewage disposal engineering, or you may say people use it everywhere. Okay, that's nothing wrong, you can use wherever. But important point is long-term use. When we consider that some product is for long term, then value of its production becomes very important. If you have to use some product say for 5 decades, you cannot just ignore it. Yes, if you have some metal, say today I buy it and throw it, one day use, or once you use it and then it's of no use, there you may say, okay, first of all, that is not based on construction, that's not based on production, it's based on natural. Nature always gives quality, we have to find it. Consumable items like fruits, like vegetables, you have no role into that. Whatever quality exists, that is because of its own, or you can say nature. Now we have to deal with in our life with construction, production, manufacturing, services, education, society, and individual. And my focus is on individual. My focus is on individual because it is individual that is more important in procedure, in work. And it is individual who handles communication and coordination, construction. It is individual who handles manufacturing and who you can say delivers services. Therefore, if individual is controlled, if individual is streamlined, if individual is well profiled, I can say engineering can move in right direction. This impact of engineering and on engineering and by engineering itself throughout the world. It's not only in our country. I have seen many countries are very good in engineering, but nowadays I think there is deterioration everywhere because of many reasons. First of all, use of computer, that is excessive use of computer, does not mean good engineering. Because one who uses computer, he starts depending on computer and he starts avoiding excessive use of mind, which is required. Excessive use of mind, only one point is positive in life, which is considered negative otherwise. They say, it's said that excess of everything is bad. That's okay, excess of everything is bad, but excess use of mind is always good. Excess use of mind is always good. Maybe sometimes it does not give anything, but it brings something to world. If I use my mind by blessings of superpower, because it's superpower ultimately, that gives me something, it's not my own. So excessive use of mind is only something that, first of all, nothing is required to be paid for its use, and otherwise it can give you immense benefits. It can keep your mind superactive. It can give you conceptual life, and that conceptual life can be converted to physical being if it is successful. So as we say, life is engineering based, I should say life is mind based also, because engineering means use of mind. Engineering means application by mind, and engineering means calculations by mind. Calculations does not mean mathematical calculations. This means calculations in principle, calculation of time, calculation of activities. You can describe it in whatever way. It is engineering that tells us what to do, how to do, what's way out, and that becomes one-time formula. How many times we get success, it becomes a reference for future. We use past references and we plan for future. And particularly in profession. Profession means we have to study in depth. That is profession. We cannot leave it to circumstances. We cannot leave it to okay. We have done it, that's fine. Don't think, stop thinking on this. That never works. Just like our body is dependent on respiration, on you can say breathing, same way life is dependent on use of mind. And use of mind is something that cannot be measured. You cannot measure use of mind, because mind is such a powerful tool. I just try to give you some information every day regarding this file, and this file says safety first and I say quality must. Safety is first, that's okay, it should be respected, and we can say no one has got any right to give undue pains to others. No one has gotten any right to condemn quality requirements, because quality is also paid for when product is purchased. But here I use my mind, it's also product, but it's not paid for. I can use this product excessively, nobody sends any bill. Same way I can use nature excessively and nobody would send any money bill. It's a very important point. We say if you know safety very well, if you apply safety, you won't feel any pain. But if you do not apply safety, you do not understand it very well, you do not respect it, and certainly you shall encounter pain and it will be out of your control. You may not be able to digest it. Same way we can say you have to understand quality, you have to know quality if you want to be happy in work. You don't want to see any adverse results. Adverse, you can say the chain reaction, then there should be no pain if you understand it, if you use it. And also if you don't understand this, don't use it. If you ignore quality, certainly you shall have to see pain and it shall ignore you, everything. And we say it is necessary everywhere. And ultimately I can say that quality has to be complied with, defined, specified, stated requirements, because quality parameters, quality criteria is always defined or it is understood. What are standards? Or you can say it has to be specified everywhere or at least on work direction. It has to be specified. What are stated requirements? We can say stated requirements, not simply spoken requirements. Stated means written or requirement which is mandate. Stated demands, these must be fulfilled, or you must write something that is within limits. And whatever is given, that must be complied with on contracts. That's called contracts performance. We don't do that. This means I'm not honest, you can say. I must be honest. I must be faithful to myself. I must have attitude to do work. And I cannot say I should have positive attitude only, I should have negative attitude as well. Or I can simply differ with other opinions that you should have only positive attitude in life. I must have both attitudes. Only then I can compare how it works. How does positive work and how does negative work? You cannot call life is positive only because positive and negative work together in sequence. Negative is not bad while positive is not good. Both are same. It depends on our approach, what is positive and what's negative. But what I say, what is useful in a pattern that it helps us, it's called positive attitude. And what we say goes against us, which I consider and you consider respectively and relatively. That is negative, we call it now it's negative. But we should not forget, negative is always not bad. It can be bad to your relational thinking. It cannot be bad for every thinking. Negative, if you take mathematics and consider it, negative is very important. Without negative, we cannot think. In fact, thinking is negative. If you compare to world, if you compare this mundane world, thinking is always negative. What you can't see is called thinking. What you can't see is called negative. And what you can say, okay, it's positive means we can see through eyes in this mundane world. And we have to stay in this mundane world. We cannot say engineering is applied in this mundane world. How can we apply otherwise? Tell me. When we apply engineering, it's on this earth. It's not in heaven. And that's what is mundane. So engineering is related to mundane world. In material world you can otherwise. Physical world you can otherwise. It's not spiritual world, but it is supported by spiritual world. It is supported by soul world, and that subject is out of scope in this talk. But we have to keep that in mind that my thinking, my contemplation, my school of thoughts are all based on thinking, and thinking has complete relation, absolute relation to, you can say, to production. If I am an engineer, this means I studied some time in my life. That was theoretical study or school study or university study. We just put something in my mind that you can use your mind in life. That's what's meaning of studies, education, academics. Academics doesn't give you a power to do something, but it helps everyone to use mind, how to use mind in a proper way, how to use mind in a particular field or particular work. It doesn't give us common sense. We have to make use of our common sense, and common sense means engineering sense. Because we know sequences, we know activities, we know we walk using feet and legs, we don't walk using head. But we walk using head also, internally. We walk using head when we think. It's head that walks in. So you can say plus and minus both are there. If you say somebody walks on head, nobody will accept it. But walking on head is very important as far as thinking is concerned. So I always give more value to thinking, activity of thinking, because thinking is my power everywhere. If I have to help people, I have to think, and have to think in a way how to make people better, how to make products better, how to achieve quality, not only in products but also in my own approach, in dealing with people, in dealing with world, and how to understand quality. It's really very important subject. It's very important word. It's much more than subject. I don't want to bore you, but it's required. I move on to some other point. I was talking about concrete yesterday. Concrete is something that cannot be taken for granted. We cannot take concrete for granted because concrete is very specific item. In a way, concrete you can say is something that comes in contact and use with everybody. It used by everyone, and you can say it's used by everyone and it's very important. In a way that we can say we use concrete every day in our life, we use every day. We cannot move without it. Maybe sometimes we do not note it, but we use it. Everywhere, in all countries, in all states, you can say, concrete is used and we should respect it. Bricks are used. We use blocks, hollow blocks and solid blocks, and those blocks are made of concrete of different classes, or we can say different sizes. So that is concrete. We do bricks, we can say bricks are of course not concrete, but that is soil, which is very important. Bricks, we can say bricks are produced by clay. Clay means soil, and concrete comes from solidified soil, you can say solidified material, which is called rock. Concrete aggregate means rock, stone. Concrete comes from there itself. Concrete is a combination of stone, or you can say sand, as well as water, cement, and cement you can say limestone, silica, and many chemicals. So if you go into depth of that, ultimately we find nature exists there. Without that, it's not possible to do anything. There is nothing in this world which is not related to nature. Every item we use, every material we use, even a drop of water we use, that comes from nature. Nothing comes from us. We only use available products, available items, raw products, raw material, for refining that to particular state, and that concrete is one state. Concrete is a combination of ingredients like rock or stone aggregate, we call it on engineering term aggregate, and also fine aggregate like sand, and you can say we use cement as mixing material, cementing material, joining material, and which itself is a product of original material, and that is limestone, which is natural, silica, which is sand, is natural, and also we use water, which is natural. That's why it's very important point to understand engineering is based on raw materials, and to understand more and more, one becomes engineer, one becomes technocrat. Otherwise, these points here in this, I think we talked some, we missed that video in recording. That's why I want to go back and see where we stopped talking or what I did. I don't exactly remember. We were talking of quality control charts, and we had gone to fibers concrete mixing, which we did study, and these were hardened tests for fiber reinforced concrete we did, and also we did, you can see that if you remember. Then quality control charts says, let us also refer to this batch mixing, that is frequency of test on hardened fiber reinforced concrete, batch mixing, and when you can say fibers are shotcrete, etc. We did that. I don't waste time on that. Then you can just remember fiber reinforced concrete, and before that it was concrete strength test. They had to test in 7 days, 28 days these cubes. Likewise, we studied that one. Now we can say hardened test for fiber reinforced concrete, and when post-crack fractural performances use a basis for acceptance of fiber reinforced concrete, make conditions and test sets for test. Okay, we had this, then batch mixing we did. So now let's say quality control charts. Let's start from here, because we have to take some is lining to start with. It can be repeated in future also, no issue, because I cannot take all time here just to repeat. Here's contractor term again starts. The contractor shall submit. Contractor shall submit, submit what? Contractor shall submit a continuous statistical analysis. Contractor shall submit a continuous statistical analysis on a monthly basis for strength showing potential strength of concrete, variations in measured strength by determining standard deviation or margin, batch to batch variation of proportions and characteristics of constituent materials in concrete, production, delivery and handling process, and climatic conditions and variation in sampling specimen. Contractor shall provide in its analysis mean strength, calculated standard deviation, normal distribution of concrete strength, and frequency histograms. Contractor shall draw upper and lower lines for warning line, target mean strength plus minus 2 standard deviation, and control line, that is target mean strength plus minus 3 into standard deviation. So there are two lines shown here on that upper and lower lines for warning. You can say warning, which means target mean strength plus minus 2 standard deviation, and control line, that target mean strength plus minus 3 standard deviation. Contractor shall use methods to compute standard deviation along with coefficient of variation and whatever factors for computing within test standard deviation from range. Now recalculated margin, if adopted by engineer, becomes current margin for judgment of compliance with specified characteristic strength of concrete. This recalculated margin, you can say, if adopted by engineer, becomes current margin for judgment of compliance with specified characteristic strength of concrete. Now we say work test cubes. We always know that cubes are taken as site samples while pouring concrete. Test cubes shall be taken as specified from fresh mixed concrete which is used in work or included in work, rather we should not say used, is included in works, and which has been prepared in a normal way. What these cubes inform? Cubes shall be numbered like this, we have to give some references, and that's what time, date and name of individual, section of work from which sample is taken, and what is mixed reference, delivery note number, name of technician, and whatever relevant information means we have limit on that. But we can record is, we can give some number to cube and record it on that, otherwise everything there write on cube, it's not possible. Yes, date we can write in very you can say very different way. Date can be written or we can record somewhere if you cannot write. So times, now maybe everything cannot come on that, but we should have record of all these. Or better we write some number on that and then we record somewhere else all this information, that is time, date, individual name, which section of work and which samples are these, what is reference and what's delivery note number, name of technician and whatever other information that is relevant. We can record by giving some number to it, and that numbers in sequence should continue. Well, it's up to you how you take it. Now test for slump. We have to conduct test for slump according to requirement, according to codes, that's BSE and 123502, and temperature shall be made and recorded whenever samples are. I'm just not using in my talk hyphen or dash. You can see it on file and you can note it, no problem. Cube manufacturer shall be in accordance with this same code BSE and 12390-2 in SIM. Self-compacting concrete is used. Concrete specimen shall not be consolidated in molds, means no compaction is required. Actually placed in single lift and no layers are required, and labeled and minimum manipulation. All sample be molded at job site on a labeled surface area within 20 per meter with tolerance. All samples shall be molded on site, means of course this don't be somewhere else. It should be where work is done, because that slump is important when you pour. There can be change in slump during if you just keep it transporting or keep it rotating with whatever speed RPM. Immediately after molding and finishing, a specimen shall be stored for a period of 48 hours in a temperature range 20 to 26 degrees Celsius, or you can say air conditioned range. It's like that, 20 to 26 air conditioned range, and in an environment preventing moisture loss from specimen. In this temperature range 20 to 26 degrees, there can be no moisture loss. Specimen shall not be transported or handled until at least 14 hours after that casting. Transportation time from site to laboratory for final curing and strength testing shall not exceed 4 hours. Means it shall be long distance travel. Specimen shall be protected from direct sunlight or rapid evaporation and placed on cushion layer to reduce vibration. Rejection of concrete mixes. What is here? Rejection of concrete mixes. We are going to talk in concrete mixes shall be rejected if these fail to meet one or more requirements which cannot be brought into compliance as related. And we can say how, when improper class or grade of concrete, whatever is required is not delivered, it is rejected. If you require 25, say 30, I require 30 and I get only 25, means it is rejected. It's not class I require, though it is not rejected otherwise, but to this work, for interest of this work, for use on this work, this is rejected. Slump or temperature not within the specified limits, it must be, it is rejected. If it is not, it exceeds slump considerably, it exceeds temperature considerably, we cannot accept this. And our size aggregate, if size aggregate is 20 mm maximum size, it cannot be used in a way 40 mm used. So 40 mm or other in range between this 20 and 40 or 25, 40, we can't accept that. The maximum water cement ratio is exceeded. Let's say it's 0.3 or 0.35 and it's given 0.5. There's no way I can accept this. It's no way, no question. And there'll be more points, means let me say, concrete shall not be rejected unless it has been visually inspected by engineer or representatives. Of course, they have to view it. Without that, we cannot reject that. And of course, it's based on experience and practice and people's understanding and people's conduct, how they want to work. Now, unsatisfactory concrete works is a very important point. Unsatisfactory concrete work means if work is unsatisfactory, there's no way we use it. Yes, that's right. What to do with that? We have to test it. How to do that test? And that's the important point. Says a test shall be average. A test shall be average of strengths of a specimen. Test shall be average of strengths of a specimen tested at age specified. If a specimen shows definite evidence other than low strength, if a specimen shows definite evidence other than low strength of improper sampling, improper molding, improper handling, improper curing or testing, it shall be discarded and the strength of remaining specimen be considered for our calculation, or you can say test results. And where range of test values is more than 15% of mean, where range of test values is more than 15% of mean, results shall be disregarded unless an investigation reveals an acceptable reason to justify disregarding an individual test value. It's a very important point. It says strength of remaining specimen which are not rejected, strength of remaining specimen that have not been rejected should be or shall be considered as test results, and where range of test values remains more than 15% of mean value, result shall be disregarded unless an investigation tells or reveals or justifies acceptability regarding an individual test value after investigation is conducted. To conform to requirements of this specification, strength tests representing each class of concrete must meet whatever requirements. These are following requirements. And what are these? Average of whatever any three consecutive strengths, average of consecutive three strengths tests, or you can say average of any three consecutive strength tests shall be equal to or greater than specified strength F-C. F-C. When specified strength is 35 MPa, say, when specified strength is 35 MPa or less, no individual strength test average of at least two specimen tests shall be more than 3.5 MPa. Means 35 plus 3.5 maximum. Or what you say? No, not like when specified strength is 35 MPa or less, no individual strength test average of at least two specimen tests shall be more than 3.5 MPa below specified strength. So specified is 35 minus 3.5, that should be 31.5. It should not be below that specified strength. Minus 3.5 MPa if it is up to 3.35 MPa. When specified strength is greater than 35 MPa, no individual strength test average of two specimen tests shall be less than 0.9 F-C. So in case it is higher than, it's greater than 35, let us say it's 40 MPa. In that case, you can say no individual strength test average of two specimen tests shall be less than 0.9 FCA. 0.9 FCA in case of 40 is 36. It should not be less than that. Means 10% margin is given here, and in previous case it was 3.5 MPa, which is also 10%. So it can be a consideration like this up to 35 MPa. It should not differ more than 3.5 MPa, while in case of 35 and above it should be 0.9 FC. So these are some points that have been added later on. In previous one, long back, these were not available, and we used to say with 35, okay, it should be acceptable. With 36 or 38 or 40 or 45. Now question is, should these test results be unsatisfactory, or should certain test results be unsatisfactory? Engineer may order work be stopped. Work be stopped pending further instructions, and whatever work executed for which the results are unsatisfactory shall be liable to rejection, and if so advised for rejection, work shall be rebuilt at contractor's expense. Means if concrete does not satisfy these conditions, as we said, it is rejected. Investigation of course shall be done, but probability is that work shall be rebuilt, and which is huge loss, great loss, time loss, cost loss, material loss, of course respect loss. In case of 7 days work cubes test proving satisfactory, in case of 7-day work test proving unsatisfactory, work may be stopped. Work may be stopped and may be stopped and liable to rejection pending results of 28 days test. If test results fail to comply with requirements, work represented shall be immediately liable to rejection. It's a very important point. You have to wait till 28 days. We have to wait from 8th day to 28th day to make sure that new results justify, new results succeed. But if it fails, then no way, work has to be done again. There may be other problems we can see from case to case, but it is plain statement, it is plain specification condition that if your concrete fails on 7th day test, it is to be considered, it may fail on 28 days, and 28 days test is considered conclusive, decisive. Cost of all such cuttings, preparation of specimen, we are talking of specimen preparation, cost of such cuttings, preparation of specimen, transportation and testing, and of making good portions of structure affected shall be borne by contractor. Of course, contractor has to bear all such because it is contract. Regardless of satisfactory test cube results, this is also another way. Even if your tests are satisfactory, these tests pass. Even then, question is, regardless of satisfactory test cube results, or you can say whatever concrete work which in an engineer's opinion is excessively honeycombed. Honeycombing is a very important defect. Regardless of satisfactory test of cubes, whatever concrete work which in engineer's opinion is excessively honeycombed, or in whatever way or in any other way is defective, it shall be liable to be rejected. It shall be liable to be rejected. Minor defects apparent on stripping formwork must be made good at contractor's expense. No such repair work shall be carried out until it is inspected and until after inspection by engineer and its acceptance of proposed treatment has been given by engineer or given by contractor and approved by engineer. Work which has not been previously inspected but which shows signs of such treatment shall be liable to be rejected as defective work, and cost of all delays on site due to faulty concrete work shall be met or borne by contractor. Now we are going to talk about concrete plants. Concrete plants, batching plants it is generally, and in this case it has the general and scope references. In batching general, plant type, bins and weight batchers, tolerances of measuring equipment, batching tolerances, charging, mixer, mixing, charging concrete materials, mixing time for stationary mixers, mixing, limitation of water cement ratio, ready mix concrete, general, appendix A, concrete plant inspection. So here, concrete plants. It is general. This part covers batching and mixing of concrete together with inspection of concrete plants. And related sections in this part are: first is general, then aggregates, cementitious materials, water admixtures, property requirements, transporting and placing of concrete, hot weather conditions or concreting, miscellaneous. And we have references here. That is guides for measuring, mixing, transporting and placing concrete, specification for ready mix concrete. I am not reading references numbers, you can see yourself. Testing concrete, concrete specification complementary, and testing of hardened concrete, testing hardened concrete part 1, the shape, dimensions and and other requirements and for specimen and molds. Testing hardened concrete part 2, making and curing specimen for strength tests, and testing hardened concrete specimen part 3, compressive strength of test specimen, then testing hardened concrete specification for testing machines, compressive strength, it is compressive strength, and part 4 compressive strength specification of testing machines, and you can say testing hard concrete part 5, flexural strength of test specimen, testing hardened concrete part 6, tensile splitting strength of test specimen, testing hardened concrete part 7, density of hardened concrete, and testing hardened concrete part 8, depth of penetration of water under pressure, testing fresh concrete, testing fresh concrete part 1, sampling, testing fresh concrete part 2, slump test, testing fresh concrete part 3, Webby test, testing fresh concrete part 4, degree of compatibility, testing fresh concrete part 5, flow table test, testing fresh concrete part 6, density, testing fresh concrete part 7, air content, pressure methods, concrete specification performance, production and conformity, testing of concrete part 1, sampling of fresh concrete, testing of concrete part 2, properties of fresh concrete, testing of concrete part 3, making and curing test specimen, testing of concrete part 4, strength of hardened concrete, testing of concrete part 5, properties hardened concrete other than strength, testing of concrete part 6, sampling, preparing and testing of concrete core, testing of concrete part 7, non-destructive test on hardened concrete, testing of concrete part 8, determination of dry shrinkage of concrete for samples prepared in field or in laboratory, testing of concrete part 9, determination of creep of concrete cylinders in compression, testing of concrete part 10, determination of static modulus of elasticity in compression. Now patching. During measurement operations, aggregates shall be handled in a manner to maintain their desired grading. Desired grading and all materials weighed to tolerances required for desired reproducibility, for desired reproducibility of selected concrete mix. Coarse aggregate shall be controlled to minimize segregation and undersized material. Fine aggregate shall be controlled to minimize variations in grading, giving special attention to keeping finer fractions uniform and exercising care to avoid excessive removal of fines during processing. Avoid blending two sizes of fine aggregate by placing alternate amounts in bins or stockpiles or when loading cars or trucks. Satisfactory results are achieved when different size fractions are blended as they flow into a stream from regulating gates or feeders. A more reliable method of control for a wider range of plant and job conditions, however, is to separate storage, handling and batching of coarse and fine fractions. Stockpiling, I'll repeat this, I'm just reading it first. Stockpiling of coarse aggregate. Stockpiling of coarse aggregate shall be kept to a minimum because fine tends to settle and accumulate. When stockpiling is necessary, use of correct methods minimizes problems with fines, segregation, aggregate breakage, excessive variation in gradation and contamination. Stockpiles shall be built up in horizontal or gently sloping layers, not by end dumping. Trucks, loaders and dodgers or other equipment shall not be operated on stockpiles because, in addition to breaking aggregate, they frequently track dirt onto piles. Stockpiles located to prevent contamination, arranged to assure that each aggregate as removed from its stockpile is distinct and not intermingled with others. Concrete supplier is asked to separate storage bins and compartments for each size and type of aggregate, properly constructed and charged to prevent mixing of different sizes or types. Sequence and blending of ingredients. Sequencing and blending ingredients during charging of mixer shall be carried out in such a way as to obtain uniformity and homogeneity in concrete produced as indicated by such physical properties as unit weight, unit weight slump, air content, strength and air-free mortar content in successive batches of same mix, proportions and as stated in ASTM C94 Annex A. Mixed recipe for mixes to be produced shall be readily available to mixer operators. Only authorized personnel shall be allowed to make changes to mix design. All cement bags shall be stored in weather-tight, properly ventilated structures to prevent absorption of moisture. Storage facilities. Storage facilities for bulk cement. Storage facilities for bulk cement and bulk cements shall include separate compartment for each type of cement used. Interior of a cement silo shall be smooth with a minimum bottom slope of 50 degrees from horizontal for a circular silo, that is 50 degrees from horizontal for a circular silo and 55 to 60 degrees for a rectangular silo. Silos shall be equipped with non-clogging air diffusers. Non-clogging air diffusers flow pads through which small quantities of dry, oil-free, low-pressure air can be introduced intermittently at approximately 3 to 5 psi or 20 to 25 kPa to loosen cement that has settled tightly in silos. Storage silos shall be drawn down frequently, preferably once per month, to prevent cement caking. Each bin compartment from which cement is batched shall include a separate gate, screw conveyor, air slide, rotary feeder or other conveyance that effectively allows both constant flow and precise cutoff to obtain accurate batching of cement. Fly ash, ground slag or other pozzolanas shall be handled, conveyed and stored in same manner as cement. Bins, however, shall be completely separate from cement bins, without common walls that could allow material to leak into cement bin. All bins and silos shall be properly tagged at silos, bins, and near charging hose. Charging hose. Bags of cement should be stacked on pallets or similar platforms. Similar platforms to permit proper circulation of air. For a storage period of less than 60 days, stacks back no higher than 14 layers, and for longer periods, no higher than 7 layers. Water batcher and water pipes should be leak free. If ice is used, ice facilities, including equipment for batching and transporting to mixer, should be properly insulated. It's a very important point. We have to understand this. It's not seen here. I'm going to read that. So my processor processing place. Just a minute. Just a minute. Don't press. So 20. I think it's not available. I'm finding that. Okay. All right. During measurement operations, just going through, reading again because it should be clearly understood first. During measurement operations, aggregates shall be handled in a manner to maintain their desired grading, and all materials shall be weighed to tolerances required for desired producibility of selected concrete. mix. We are talking about batching equipment, batching machine or batching plant. You can call it batching plant or central mixing plant. And I'm just going to speak what's written on this on this specification, and then we can think on what it is. Coarse aggregate shall be controlled to minimize segregation and undersized material. Fine aggregate shall be controlled to minimize variation in grading, giving special attention to keeping finer fractions uniform and exercising care to avoid excessive removal of fines during process. Avoid blending two sizes of fine aggregate by placing alternate amounts. Avoid blending two sizes of fine aggregates by placing alternate amounts of bins or stockpiles or when loading cars or trucks. Satisfactory results are achieved when different size fractions are blended as they flow into a stream from regulating gates or feeders. A more reliable method of control for a wide range of plant and job conditions. However, is to separate storage, handling and batching of coarse aggregate and fine fractions. Stockpiling of coarse aggregate. Stockpiling of coarse aggregate shall be kept to a minimum. Stockpiling of coarse aggregate shall be kept to a minimum because fines tend to settle and accumulate. When stockpiling is necessary, use of correct methods minimizes problems and fines, segregation, aggregate breakage, excessive variation in gradation, and contamination. Stockpiles shall be built up in horizontal or gently sloping layers, not by end dumping. Trucks, loaders and dozers or other equipment shall not be operated on stockpiles because in addition to breaking aggregate, they frequently track dirt onto piles. Stockpiles located to prevent contamination. Stockpiles located to prevent contamination arranged to assure that each aggregate as removed from its stockpile is distinct and not intermingled with others. Concrete supplier is asked to separate storage bins or compartments for each size and type of aggregate properly constructed and charged to prevent mixing of different sizes of types. Sequencing and blending of ingredients during charging of mixtures shall be carried out in such a way as to obtain uniformity and homogeneity in concrete produced as indicated by such physical properties as unit weight, slump or content, strength and air spray, mortar, content in successive batches of same mixed proportion. Mixed recipe for mixes to be produced shall be readily available to mixer operator. Only authorized personnel shall be allowed to make changes to mix design. Cement bags shall be stored in watertight or weathertight, properly ventilated structures to prevent the absorption of moisture. Storage facilities for bulk cement shall include separate compartments for each type of cement used. Interior of cement silos shall be smooth with a minimum bottom slope of 50 degrees from horizontal for a circular silo and 55 to 60 degrees for a rectangular silo. Silos shall be equipped with non-clogging air diffusers. Flow pads through which small quantities of free, dry oil free, low pressure air can be introduced intermittently at approximately 3 to 5 to 20 to 35 kPa to loosen cement that has settled tightly in silos. Storage silos shall be drawn down frequently, preferably once per month, to prevent cement caking. Each bin compartment from which cement is batched shall include a separate gate, screw conveyor, air slide, rotary feeder, or other conveyance that effectively allows both constant flow and precise cut off to obtain accurately patching off. Fly ash, each bin compartment from which cement is batched shall include separate gates, screw, conveyor, air, slide, rotary feeder, or other conveyance that effectively allows both constant flow and precise cutoff to obtain accurate batching of cement. Fly ash, ground slag, fly ash or GGBS or other pozzolas shall be handled, conveyed and stored in same manner as cement. Bins, however, shall be completely separate from cement bins without common walls that could allow material to leak into cement bins. All bins and silos shall be properly tagged at silos, bins and near charging hose. Bags of cement should be stacked on pallets or similar platform to permit proper circulation of air for a storage period of less than 60 All bins and silos shall be properly tagged at silos, bins and near charging hose. Bags of cement should be stacked on pallets or similar platforms to permit proper circulation of air for a storage period of less than 60 days. Stacks bags no higher than 14 layers and for no longer period. Alright, water basher and water pipe should be leak free, and before that we can say bags of cement should be stacked on pallets or similar platforms to permit proper circulation of air for a storage period of less than 60 days. Stack bags no higher than 14 layers and for longer periods no higher than 7 layers. Water basher and water pipes should be leak free. If ice is used, ice facilities including equipment for batching and transporting to mixer should be properly insulated to prevent ice from melting before it is mixed. So we have gone through theory of plant. How does plant work? How should it be used? Ultimate requirement is that there should be no conflict in material, and then there's time to mix up. This should mix up and become ready once it's over. Plant type: manual control batching and then automatic control batching. Both are available. When we talk of plant type, see manual control batching, manual plants are acceptable for small jobs having low batching rate requirements. Generally for jobs up to a total concrete quantity of 1000 meter cube and 10 meter cube per hour. 10 meter cube per hour. Semi-automatic control batching. In semi-automatic control batching, aggregate bin gates for charging batches. Semi-automatic control batching. In this system, aggregate bin gates for charging batches are opened by manually operated push buttons or switches. Gates are closed automatically when designed weight of material has been delivered. Automatic control batching. Automatic batching of all materials is electrically activated by a single starter switch. However, interlocks shall interrupt batching cycle when scale has not returned to plus minus 0.3% of zero balance, or when weighing tolerances detailed in class 75 of this part are exceeded. So manual batching, semi-automatic control batching, and automatic control batching. Bins and weigh batches. Bins and weigh batches. Bins and weigh batches. Weight batches and batch plant. Batching plant bins shall be of sufficient size to effectively accommodate production capacity. It's a very important point here. We have to see that, and of course it is let us see what is happening here. I don't know. Okay, sorry, little disturbance was there. So, batch plant bins shall be of sufficient size. First of all, we have to see this point. Batch plant bins shall be of sufficient size to effectively accommodate production capacity of plant. Compartments in bins separate various concrete materials and shape, and arrangement of aggregate bins shall prevent aggregate segregation and leakage. Batch plant bins shall be of sufficient size to effectively accommodate production capacity of plant. Compartments in bins separate various concrete materials, and shape and arrangement of aggregate bins shall prevent aggregate segregation and leakage. Weight patchers shall be charged with easy operating clamps, shells, or undercut radial types bin gates. Weight patchers shall be charged with easy operating clamp shells or undercut radial type bin gates. Gates used to charge semi-automatic and fully automatic batchers shall be power operated and equipped with suitable in-flight correction to obtain desired weighing capacity accuracy. These shall be calibrated by plant supplier for types of aggregate used at standard range of moisture content. Weigh batchers shall be accessible for obtaining representative samples and arranged to obtain proper sequencing and blending of aggregates during charging of mixer. Amount of concrete mixed in one batcher shall not exceed rated capacity of mixer. All mixing and batching plants shall be maintained free of set concrete or cement and be cleaned before commencing mixing. For each different type of cement at use at plant, a separate cell ISO be provided. I read again. It says, it's actually plant type, manual, control, and be set also semi and automatic. And it says that in manual control it is up to 10 meter cube per hour. Manual control plants are acceptable for small jobs having low batching rate requirements, generally for jobs up to total concrete quality of 1000 meter cube and 10 meter cube per hour. Semi-automatic control batching in this system aggregate bin gates for charging batches are opened by manually operating push buttons or switches. Gates are closed automatically when designated weight of material has been delivered. Automatic control batch, you can say automatic batch of all materials is electrically activated by a single starter switch. However, interlocks shall interrupt batching cycle when scale has been turned to plus minus 0.3% of zero balance, or when weighing tolerance is detailed in clause of this part. Bins and weigh batchers. Batch plant bins shall be sufficient size to effectively accommodate production capacity of plant. Compartments in bin separate various concrete materials and shape and arrangement of aggregate bin shall prevent aggregate segregation and leakage. Weight batchers shall be charged with easy operating clamp shells or undercut radial type bin gates. Gates used to charge semi-automatic and fully automatic batchers shall be power operated and equipped with a suitable in-flight correction to obtain desired weighing accuracy. Shall be calibrated by plant supplier for subtype of aggregate used at standard range of moisture contents. Weigh batcher shall be accessible for obtaining representative samples and shall be arranged to obtain proper sequencing and blending of aggregate during charging of mixer. Amount of concrete mixes in one batch shall not exceed rated capacity of mixer. All mixing and batching plants shall be maintained free of set concrete or cement and shall be cleaned before commencing mixing. For each different type of cement at use at plant, a separate silo shall be provided. Tolerance of measuring equipment. Tolerances of measuring equipment. Scales for weighing concrete ingredients shall be accurate when in use within ±3% and 1 ±1.5% for additives. Concrete ingredients shall be accurate when in use with ±3%, that is scales value, and ±1.5% for additives. Standard test weights shall be available to permit checking of scale accuracy. That is, standard test weights shall be available to permit checking of scale accuracy. Testing of testing of weighers shall be at 3 months interval. If water is dispensed by flow meter, frequency of testing shall be at 3 months intervals. If such testing be undertaken by a calibration company approved by client, approved by Central Materials Laboratory and calibrated to recognize international standards, test certificate shall be displayed in plant in prominent position. Tolerances, batching tolerances. Operation of batching equipment. Operations of batching equipment shall be such that concrete ingredients are consistently measured within following tolerances. Plant shall have ability to flag values that are outside these limits. Operators shall make manual adjustments to batching and final weights shall be within given limit state. Batching tolerances. Operation of batching equipment shall be such that concrete ingredients are consistently measured within following tolerances. Plant shall have ability to flag values that are outside these limits. Operators shall make manual adjustments to batching and final weights within given limits, that is given table, any or whatever adjustment is displayed on batch weight printouts. Cementitious materials shall be measured by mass when supplementary cementitious materials are used in concrete mixtures. Cumulative mass is permitted to be measured with hydraulic cement when supplementary cementitious materials are used in concrete mixtures. Cumulative mass is permitted to be measured with hydraulic cement but in a batch hopper and on a scale which is separate and distinct from those used for other materials. Aggregate shall be measured by mass. Batch mass measurements shall be based on dry materials and shall be required masses of dry materials plus total mass of moisture, both absorbed and surface, contained in aggregate. I repeat because it was disturbed due to some incoming bell of telephone. People usually call irrelevantly. I don't understand what they do. My means MD Amjad. They used to call from MD Amjad. Is that? कोई यार क्या करना क्या है? Just disturbing for nothing, you know. Aggregate shall be measured by mass. Batch mass measurement shall be based on dry materials and required masses of dry materials plus total mass of moisture, both absorbed and surface, contained in the aggregate. So 2 points were there. Cementitious materials shall be measured by mass. When supplementary cementitious materials are used in concrete mixtures, cumulative mass is permitted to be measured with hydraulic cement, but in a batch hopper and on a scale which is separate and distinct from those used for other materials. Aggregate shall be measured by mass. By mass, batch mass measurements shall be based on dry materials and required masses of dry materials plus total mass of moisture, both absorbed and surface, contained in aggregate. Mixing water shall consist of water added to batch, ice added to batch, water occurring as surface moisture on aggregates, and water introduced in form of admixtures. Added water shall be measured by weight or volume. Added ice shall be measured by weight in case of truck mixtures. Whatever wash water retained in drum for use in next batch of concrete shall be accurately measured. If this proves impractical or impossible, wash water shall be discharged prior to loading next batch of concrete. Chemical admixtures in powdered form shall be measured by mass liquid ambience. So chemical admixtures in powder form shall be measured by mass. Liquid chemical admixtures shall be batched by mass or volume. This is table. Batching tolerances ingredients. Is typical batching tolerance ingredients, then batch weighs greater than 30% of scale capacity. Individual batch and cumulative batch, then batch weighs less than 30% of scale capacity. That is individual batch and cumulative batch. How many items are there? You can see one is cement and other cementitious materials, then water by volume or weight percentage, aggregate percentage, admixtures by volume of weight percentage. These are only these. So we can say in this case cement and other cementitious materials plus minus 1% required mass or plus minus 0.3% of scale capacity, whichever is greater. This batch weighs greater than this. plus 1% of required mass, cement, other cement materials, minus 1% of required mass of plus minus 0.3 of scale capacity. Individual batch and cumulative batch, also this is weight batch less than 30% scale capacity. This is not less than required weight of 4% more than required weight. Water by volume or percentage or weight percentage. In individual batching, it is plus minus 30%, plus minus 1%, and not recommended for cumulative batching. And also in case of batch weighs less than 30% of scale capacity, 22 plus minus 2%, and in aggregate percent plus minus 0.3% of scale capacity or plus 0.3% required cumulative with less than this percent. Now admixtures by volume, plus minus aggregate percentage is plus minus 2. Then second is also plus minus 1. That's plus minus 2 in this case, and all four minus is given there. Admixture volume or weight plus minus 3% not recommended. Then plus minus 3 and not recommended. So this is just tabulation. Cement supplied in bags shall be placed directly from bag into intake of mixing plant, and each batch must contain one or more complete bags of cement. No mixer having a rate capacity of less than a one bag is a batch shall be used. No mixer having a rated capacity less than one batch shall be used, and the Now, cement supplied in bag shall be placed directly from bag into intake of mixing plant. Each bag must contain one or more complete bags of cement. No mixer here having a rated capacity of less than one batch shall be used, and mixer shall not be charged in excess of its rated capacity. Charging mixer. Each batch shall be so charged into mixer that some of water enter in advance of cement and aggregate. Each batch shall be so charged into mixer that some water enters in advance of cement and aggregate. Controls be provided to prevent batching or batched ingredients from entering mixer. Controls shall be provided to prevent batch aggregate ingredients from entering mixer before previous batch has been completely discharged. First batch of concrete through mixer shall contain an excess of cement. First batch of concrete through mixer shall contain an excess of cement to allow for coating of inside of mixing drum without reducing required mortar ability. Each batch shall be so charged into mixer that some of water enters in advance of cement and aggregate. Control shall be provided to prevent batched ingredients from entering mixer before previous batch has been completely discharged. First batch of concrete through mixer shall contain an excess of cement to allow for coating of inside of mixing drum without reducing required mortar content of mixing plant that has been out of action for more than 30 minutes shall be thoroughly cleaned before fresh concrete is mixed in it. When a change of mixing is made, mix is made to one using a different type of cement, mixing plant shall be thoroughly cleaned of all traces of previously used cement. Whatever whatever is time interval between successive mixes. When a change of mix is made to one using a different type of cement, mixing plant. Yes. I'll say let's now mixing, charging concrete materials. It's also a very important point because mixing is ultimate requirement, not and then delivery. Mixing is before delivery. It's very important part. Though it looks very simple, but it's completely technical. Water shall enter mixer first without continuous. I've gone through this. Water shall enter mixer first with continuous flow, while other ingredients are enter mixer. Water charging pipes must be of proper design and of sufficient size so that water enters at a point well inside. Water shall enter mixer first with continuous flow while other ingredients enter mixer. Water charging pipe must be of proper design and of sufficient size so that water enters at a point well inside mixer and charging is completed within first 25% of prescribed mixing time. Charging is completed within first 25% of prescribed mixing time, and where concrete uniformity shall be verified by approved inspector. Admixture shall be charged to mixer in accordance with instructions of manufacturer. Automatic dispensers used. Mixing time for stationary mixers. Mixing time required shall be based upon the ability of mixer to produce uniform, homogeneous, consistent mixture throughout batch and from batch to batch. Final mixing time be based on results of mixer performance test made at start of project and time fixed unless a change is authorized by engineer. Time shall however not be less than 60 seconds unless otherwise verified as stated hereinafter. Mixing time required shall be based upon ability of mixer to produce uniform, homogeneous, consistent mixture throughout batch and from batch to batch. Final mixing time shall be based on results of mixer performance tests made at start of project and time fixed unless a change is authorized by engineer. Time shall, however, not be less than 60 seconds unless otherwise verified as stated hereinafter. Where no mixer performance tests are made, acceptable mixing time for mixers having capacity of 0.75 meter cube or less shall be not less than 1 minute. Mixers of greater capacity, this mixing minimum shall be increased 15 seconds for each cubic meter or fraction thereof of additional capacity. Where mixer performance tests have been made on given concrete mixture in accordance with testing program and mixers have been charged to their related capacity, acceptable mixing time is permitted to be reduced for those particular circumstances to a point at which satisfactory mixing defined in ASTM C94 Annex and RMCA and RMCA certification for central mixing plants shall have been accomplished. When mixing time is so reduced, mixing time of mixing shall not exceed this reduced time by more than 60 seconds for air-entered concrete. Mixing time shall be measured from time at all ingredients are in mixer. Mixing time shall be measured from time all ingredients are in mixer. Batch mixers with audible indicators. Batch mixers with audible indicators used in combination with interlocks, which prevent mixture discharge prior to completion of preset mixing time, shall be provided on automatic plants. And also, I would desire on manual plants, which batch mixers and audible indicators used in combination with interlocks, which prevent mixer discharge prior to completion of preset mixing time, shall be provided on automatic plants and also desirable on manual plants. Mixer shall be designed for starting and stopping under full load. So here is this point very important we see. First is, it says final mixing time shall be based on results of mixer performance tests made at start of project and time fixed unless a change is authorized. Time shall however not be less than 60 seconds unless otherwise verified as stated hereinafter. When no mixer performance tests are made, acceptable mixing time for mixing or mixtures have been capacity of 0.7 meters cube or less shall be not less than 1 minute. For mixtures greater capacity, for mixtures of greater capacity, the minimum shall be increased 15 seconds for each cubic meter or fraction thereof of additional capacity. Where mixer performance tests have been made on given concrete mixture in accordance with testing program is TMC 94 Annex A NRMCA certification and RMC Ready Mixed Concrete is the National RMC Association certification, and mixers have been charged to their rated capacity, except mixing times permitted to be reduced for those particular circumstances to a point at which satisfactory mixing defined in ASTM C94 and RMC certification for central mixing plants shall have been accomplished. When mixing time is so reduced, maximum time per mixing It's a very important point that when mixing time is so reduced, the maximum time of mixing shall not exceed this reduced time or by more than 60 seconds. For air-entered concrete, mixing time shall be measured from the time all ingredients are in mixer. Both mixers with audible indicators used in combination with interlocks which prevent the mixer discharge prior to completion of preset mixing time shall be provided on automatic panels, automatic plants, and also desirable manual plants. Mixer shall be designated or designed for starting and stopping under full load. Mixing. We are talking batching plant. It's really interesting because of course it's mechanical work, but it's important from point of view of civil engineering or site engineering, or you can say field engineering, or you can say engineering in practice. Structural concrete to be placed in situ. All structural concrete to be placed in situ shall be manufactured in a computer controlled batching plant of types whatever is given. Plants shall be complete. All structural concrete to be placed in situ shall be manufactured in a computer controlled batching plant of type described in clause previously. Plant shall be complete with suitable water chilling or ice making facilities, or both water chilling or ice making facilities, both to ensure concrete temperatures are maintained as specified. Concrete shall be mixed in batches in plant capable of combining aggregates, cement and water, including admixtures, into mixture of uniform color and consistency of discharging admixtures without segregation. Automatic moisture content process or probes. Automatic moisture content probes set in hoppers shall be used to continuously determine moisture content of aggregate. Contractor shall make due allowances for water contained in aggregates when determining quantities of water to be added to each mix. Says plant shall be complete with suitable water chilling or ice making facility, or both, to ensure concrete temperatures are maintained. Concrete shall be mixed in batches in plant capable of combining aggregate, cement and water, including admixtures, into a mixture of uniform color and consistency and of discharging light radiation. Concrete shall be mixed in batches in plant capable of combining aggregates, cement and water, including admixtures, into mixture of uniform color and consistency and of discharging mixture without segregation. Automatic moisture content probes set in hoppers shall be used to continuously determine moisture content of aggregate. Contractors shall make due allowances for water contained in aggregate when determining quantity of water to be added to mix. Amount of water added to each mix shall be adjusted to Now we can say that automatic moisture content probes shut in hoppers shall be used to continuously determine moisture content of aggregate, and allowances for water content in aggregate shall be made. Amount of water added to each mix shall be adjusted to maintain constant approved water cement ratio of mixed concrete. Limitation of water cement ratio. No concrete shall exceed water cement ratio as given. Quantity of water used in mixing shall be at least amount that produce a workable homogeneous plastic mixture which can be worked into forms and around reinforcement. Excess water over maximum allowed by mix design shall not be permitted. Shall not be permitted. Now, no concrete shall exceed water cement ratio. Quantity of water used in mixing shall be least amount that produce a workable homogeneous plastic mixture which can be worked into forms and around reinforcement. Excess water over maximum allowed by mix design shall not be permitted, and whatever batch containing such excess shall be rejected. Ready mix concrete. Now, it's interesting one to have all this, but it's also interesting to go with seriousness so that we can understand what it's all about. Sometimes it is, sometimes it's not. It's of course very interesting. Really, it's very interesting. You can say, in a way, it should be or should not be, but it is. Well. Just a minute, please. Just a minute. I'm trying to find some document. Just a minute, just a minute. Yes. It's just where it's gone. I don't know where it's gone. Anyway, let me see how does it work. Where's that exact access? Anyway, so of course there's some problem in this. Ready-mix concrete. Ready-mix concrete. Manufacturer of ready-mix concrete RMC for use in government projects may only be carried out in batching plants that have an approval certificate issued by Central Materials Laboratory. Well, this is the class conditions. Don't worry about this. When this certificate is under renewal process by ready-mix concrete manufacturers, other certificates such as NRMCA shall be considered by engineer as approval on uniformity, such as uniformity and consistency of facility. Engineer may request to revalidate uniformity test under supervision. In addition, use of ready-mix concrete on whatever part of work shall require engineer's written approval. So this general I repeat. Ready-mix manufacture, ready-mix concrete manufacture for use in government projects or whatever, it may only be carried out in batching plants, not otherwise. This is a condition you can say. Contractor shall specify engineer on following issues. Materials used in ready-mix concrete comply with specifications in all respects. Manufacturing and delivery resources of proposed supplier are adequate to ensure proper and timely completion. Specified requirements as to sampling, trial mixing, testing and quality of concrete of various grades as described shall apply equally to ready-mix concrete. Every additional facility, including but not limited to testing equipment, that is workforce, laboratory facilities and transport, which engineer or persons authorized by it may require for supervision and inspection of batching, mixing, testing and transporting to site of ready-mix concrete shall be provided by contractor at no extra cost. Cost of delivery notes shall be, copies of all delivery notes shall be submitted to the engineer in duplicate on computer generated forms and include at least following information. name of supplier, serial number of ticket and date, truck number, name of contractor, name of contract and location of office, grade of concrete, specified work ability, type and source of cement, source of aggregate, nominal maximum size of aggregate, quantity of each concrete ingredients, type of admixture and quantity, water content, time of loading and departure from ready mix plant, arrival and departure time of truck, time of completion of discharge, time of completion of discharge, notations to indicate equipment was checked and found to be free of contaminants prior to batching. A copy of delivery note shall be given to engineer's representative for each load, unless approved otherwise, in advance of batching. All concrete of single design mix for 1 day's pour shall be from a single batch plant of a single supplier. Point to be remembered, it is unless approved otherwise, in advance of batching, all concrete of single design mix for 1 day's pour shall be from a single batch plant of a single supplier. Ready mix concrete conforms to BS 8500 in addition to GSO EN 2061, except materials testing and mix design as specified in this section. Transit mixers equipped with automatic devices for recording number of revolutions of drums be used. Excess water over maximum allowed by mix design shall not be added. Each mixer truck shall arrive at job site with its water container full. In event that a container is not full of concrete tests, in event that the container is not full of concrete, thus given a greater slump, then acceptable load shall be rejected. In event that container is not full or concrete, test results give a greater slump, then acceptable load shall be rejected. Shade temperature and concrete temperature. Shade temperature and concrete temperature shall be recorded at point of discharge of mixer and placement for each load to concrete. Heat of concrete delivered to site. Placement of each load of concrete delivered to site. Shade temperature and concrete temperature shall be recorded at point of discharge of mixer and at placement of for each load of concrete delivered to site. Maximum minimum temperatures and wet bulb temperatures shall be recorded daily. Slump test shall be performed in accordance with BS. Whatever is here, SAS and BS. Shade temperature and the maximum and minimum temperatures and wet bulb temperatures shall be recorded daily. Shade temperature and the concrete temperature shall be recorded at point of discharge of mixer and placement for each load of concrete delivered to site. Minimum, maximum and minimum temperatures and wet bulb temperatures shall be recorded daily. Slump test shall be performed in accordance with BSEN 12350 or relevant GSO standard point of placement. No water shall be added at site. Concrete plant inspection checklist. Concrete plant inspection checklist. General information of plant. General information of plant. You give me a few minutes. I think it's better to go and come back because of, I'll give you some page. You can read that so that you will be happy. You can mix, you can read it. I'll just zoom it. You can read this page. Meanwhile, I'll be back, okay, and I'll come back to checking issue. still there. So I think you've gone through this successfully. Now we'll go back to our point, and that's there. As said earlier, we go back to the point, and the point is here. Now checklist you're going to do, inspection checklist, and it says inspection checklist, the concrete plant inspection checklist, and this is here. You can say general information of plant, company name, inspection date, plant location, plant numbers, plant manufacturer, plant ID number, approval certificate number, contact a plant. Then factory condition, concrete floor under mixer and silos. Factory condition is concrete floor under mixer and silos. What type of concrete floor is there or doesn't exist? You have to see that. Concrete floor with slope under materials, concrete floor with slope under materials. There should be floor below materials, and what is slope of that? Hard and stable surface for axis and ramps. Floors clean, cleaning plant implements, drainage system, separated place of waste material, and separated place of water tank. Material storage and handling, cement and cementation materials, including blended cements, fly ash, GGBS, silica fumes, etc. Cementitious materials, silos of cement, outside cleaning for cement silos, cement scale calibration, a reflective color for cement silo, board clarify cement type, silos of cementitious materials, outside cleaning for cementitious silo, cementitious scale calibration, reflective color for cement station slip, and board clarify cementitious type. All cementitious materials axis of use protected under shade. Aggregate shading, aggregate separation under shading, aggregate separation in bins, aggregate scale calibration, cover for conveyor belts, board clarify aggregate type. Effective method to check level of material inside bins. Water and admixture supply. Water supply, water pipe insulated, chiller using ice plant or nitrogen cooling, water gauge calibration, admixture supply, additive storage silos, additive gauge calibration, board clarify admixture type, all admixture axis of use protected under shade, agitation system for all storage tanks or silos more than 5000 liter, requirements of concrete batching plant, certificate validity, computer controlled, plant type, computer printout, calibration validity, cleaning of plant blades. So it's that one. Certificate validity, requirements of concrete batching plant. Certificate validity, computer controlled, plant type, computer printout, calibration validity, cleaning of plant blades, laboratory, records for raw materials and cube test, grading, that is QCS, okay, grading, finds contents, percentage, finds quality, clay lumps and friable particles, clay lumps and friable particles. Lightweight feces, organic impurities, water absorption, particle density, shell content, flakiness index, chloride content, sulfate content, soundness, Los Angeles aberration, moisture content, compressive strength, other tests. Specimen testing at inspection time, method of slump test, curing of samples, water temperature of curing tank, concrete temperature at plant, concrete slump at plant. Laboratory equipment calibration, compression testing machine, sieves, balance thermometers. Recommendations. Plant representative information. Name of representative, contact number, signature, inspection by. Now, transportation and placing of concrete. This information that we provide to you about this plant is very important one. We cannot take it for granted because it should known to everybody. Maybe you are a quality person or you are inspector or you are doing investigation, you doing whatever information. All these are very important one, and I showed to you because this is very important. Don't take it that it's not our job. It's job of every concrete person, civil engineer, mechanical actor, whosoever you are. General information of plant you have to know, factory conditions you have to know, material storage and handling you have to know, and you can say water and administrative supply and requirement of concrete batching plant, laboratory, and you can say maybe you are a member of third party, then you know all this. You have the transportation, placing of concrete, and this side per part. And this will go through this. Transportation, placing of concrete channels, scope of work, references, submittals, and transportation channel, pumped concrete, records, placing concrete, general preparation, placing, compaction, continuity of concrete work, and therefore we have to say transportation, placing of concrete in general. This is scope of work. This part deals with transportation, placing, and compaction of concrete, general, concrete plants, form work, hard weather, concreting, miscellaneous, and reference, guide for measuring, mixing, transporting, and placing concrete, specification for ready-mix concrete, concrete complementary building standards, concrete specification, performance, production and conformity, Eurocode to design of concrete structures, general rules and rules for buildings, submittals. Should contractor propose to use concrete pumps for transportation and placing of concrete? Shall submit details of equipment and operating techniques that are proposed to use for approval of engineer. Method statement shall be submitted for approval for major concrete placements which shall address planned rate of placing, number of batching plants, number of trucks, number and positioning of pumps, pour sequence, quality control measures, spare equipment, whatever other factors that might affect placing of concrete. I repeat, these are minimum. You can add whatever is required. Plant rate of placing, number of batching plants, number of trucks, number of positions of pumps, pour sequence, quality control measures, spare equipment, whatever other factors that might affect placing of concrete. These are related to plants. You can add your own site factors, location factors, particular factors, timings, what time to start, which cubic meter, how many workers, all that we have given before. That is includes a part of particular concrete statement should be submitted. Method statement should be submitted at least 3 days in advance of planned pour. Detailed method statement, including every other point, must be included. This method statement should be explained like speaking document, professional speaking document. Method statement should be submitted at least 3 days in advance of planned pour. If required by engineer or someone else concerned party, a pre-pour planning meeting may be arranged with representatives from ready-mix supplier, contractor and engineer. Contractor shall submit to engineer for approval details of proposed operation and standby equipment. Transportation. Transportation, delivery and handling shall be in accordance with requirements of PS 8500 or PSCN 2061. Concrete shall be conveyed from mixer to its place of works as rapidly as possible by methods which prevent segregation or drying out, and certainly ensure that concrete is of required workability at point and time of placing. Should segregation occur in concrete, material shall be remixed to satisfaction of engineer or discarded. Furthermore, cause of segregation shall be determined and further occurrences prevented. Contractor shall ensure that time between placing of different lifts or layers of concrete is short enough to prevent formation of cold joints. Contractor shall ensure that there is a backup plant that can be used in event of breakdown, and that adequate provision has been made for number of delivery trucks. Concrete shall be transported to site in an approved type of truck, mixer or agitator truck, which apart from cab and chassis shall be painted white and kept clean all times. Discharge chute and other dirty areas shall be washed down after delivery to prevent spillage on the road. If a truck mixer or a truck body with an agitator is used for central mixed concrete, limit volume of concrete charged into truck to 80% of truck or truck volume per ASTM C94 and NRMCA requirements. If shrink mixing is approved by engineer, limit volume of concrete charged into truck to 63% of drum volume. If shrink mixing is approved by engineer, limit volume of concrete charged into truck to 63% of drum volume. A truck shall be rotated 30 revolutions at mixing speed, 30 revolutions at mixing speed before discharging concrete into assure uniformity. 30 revolutions. Insides of concrete mix trucks shall be inspected periodically and whatever build-up of concrete removed that may impair efficiency of mixing action. All trucks shall be NRMCA certified or whatever equivalent certification exists. Discharge of concrete shall be completed within 90 minutes. Discharge of concrete shall be completed within 90 minutes or before drum has revolved 300 revolutions. 300 revolutions. Whichever comes first, after introduction of mixing water to cement and aggregate, after introduction of mixing water to cement and aggregates or introduction of cement to aggregates. These limitations are permitted to be waived by purchaser if concrete is of such slump or slump flow after 90-minute time or 300 evolutions limit has been reached. It can be placed without addition of water. To batch in hot weather or under conditions contributing to quick stiffening of concrete, a time limit less than 90 minutes is permitted to be specified by engineer. Pumped concrete, access for pump shall be checked prior to pour. If access cannot be assured, contractor shall not continue with concreting operations. If approval is obtained for pumped concrete, contractor shall ensure that shock is not transferred from pipeline to formwork and previously laid concrete. During placing concrete by pumping, end hose must never reach into concrete. During placing concrete by pumping, end hose must never reach into concrete. All measures shall be taken to avoid blockage of delivery hose system. Compaction of concrete shall be carried out per standard practice procedures. Grout shall be pumped. Grout shall be pumped through concrete. Pump to provide initial lubrication. Grout shall be pumped through concrete. Pump to provide initial lubrication. Initial discharge of whatever pumped concrete shall not be incorporated in permanent works. Where concrete is conveyed by chutes or pumps, plant shall be of size and designed to ensure continuous flow in chute or pipe. Where concrete is conveyed by chutes or pump, plant shall be of size and designed to ensure continuous flow in chute or pipe. Slope of chute or presence or pressure of pump shall allow concrete to flow without use of whatever water addition to that proved by engineer to produce required consistency and without segregation of ingredients. Slope of chute or pressure of pump shall allow concrete to flow without use of any water additional to that approved by engineer to produce required consistency and without segregation of ingredients. Delivery and of chute or pipe shall be thoroughly flushed with water before and after each working period and kept clean. Water used for this purpose shall be discharged outside and away from whatever permanent works. Within 24 hours of delivery, contractor shall provide engineer with delivery notes giving information required under paragraph as above. Placing concrete. Placing concrete. We talked till now about transportation up to location as question of placing concrete. Contractor shall obtain approval approval of engineer to its proposed arrangement prior to beginning of concrete pouring. All placing and compacting concrete shall be carried out under direct supervision of a competent member of contractor staff with a minimum 5 years experience in concreting works and in a manner to produce a watertight concrete of maximum density and strength. For night concreting operations, contractor shall arrange adequate suitable lighting. Contractor shall provide safe secure access for all personnel on concreting operations. Where thickness of concrete section exceeds 600 mm, where thickness of concrete exceeds 600 mm, contractor shall adopt special precautions to be approved by engineer to avoid thermal cracking due to external and core temperature differences. Concrete shall not be placed in adverse weather conditions such as dust storms or heavy rains. No concrete shall be placed, it's a professional, no concrete shall be placed until engineer has inspected and approved in writing surfaces upon which concrete should be placed. Formwork and reinforcing steel. Contractor shall give engineer at least 24 hours notice to enable this inspection to be carried out. If concrete is not placed within 24 hours of approval being given, approval shall be obtained again before concreting. An inspection be made immediately prior to concreting to check cleanliness in forms. Wood forms, unless lined, shall be oiled or wet with water in advance of placing concrete so that joints will tighten and prevent seepage of cement grout from mix. Reinforcement shall be sprayed with a small amount of water prior to starting pour. Reinforcement shall be secured in position, inspected and accepted by engineer before placing concrete. All inserts, bolts, anchor bolts, sleeves and other embedded items shall be accurately located using templates where appropriate and held securely to prevent displacement during placing of concrete. Aluminium items shall be completely covered and protected when embedded in concrete. Except where shown on drawings, no fixture shall be attached to concrete by shot firing or drilling without acceptance by engineers. Notwithstanding whatever such authorization, contractor shall be responsible for all damages so caused to concrete and make good at its own expense. We have to, pouring is very impactful and we will take care of this. Page is I think 62 or 82. We'll take care. It's because I can't move fast on pouring. It's very important exercise. We have to discuss. It's a important item. Compaction we have to discuss then. The continuity of concrete work we have to listen. So it's a good discussion, and we cannot take it for granted just because I can speak and finish it. No, we'll take our time to understand this, how to place concrete, because it's an important item, and that's what it says there. So, well, I think we have gone through certain catalogs, certain books, specifications. It's a good specification as far as it's concerned. That's why I'm saying what we have to understand to get, and it's, preparation, etc. All this, I'll take care of this next time. We'll see you. I hope you enjoy this well in advance, and I think concrete specification it is, and I know concrete is very important material for everyone, as well engineer, structural engineer, whosoever, even those who deal with structural steel, they have to do foundations. So it's for all. Concrete must be taken care of in a professional way. That's the reason I try to gather information from various specifications so that we should know what does something say. And because I worked also in Qatar and UAE, I have some exposure of that, which I want to share with people. I think it's the best way to do that. I hope we'll see you again next time. It's going to be 3 hours around. I think must stop now for this purpose. I'll continue from this page 80 or 81 or 82, whatever it is in specifications to cover up. And we have to worry about quality. Again, I say it's all part of quality we are discussing with how best we can achieve quality system in every affairs in life, but most important point is quality is concerned. It's for concrete. Concrete is very significant material from viewpoint of projects and viewpoint of quality system. That's what we worry about. We have learned from that. So that's important. All it's inspiration to all young engineers particularly. And I am not happy that quality exists in our country or also many parts of the world. We have to be very careful to talk about this. Maybe people not so enthusiastic about this is a matter, but whoever enthusiastic, because engineering is not in reach of everybody. But even then, I try to get information as part of dissemination. Everyone in our country, or to those who are at least interested, those who are interested because responsible for quality, at least those guys got it. And this, I thank you very much. I'll see you.